Okay, here is another two-dimensional motion practice problem. Again, one that I made up, but these are pretty easy to make up. So I'm going to draw a picture right here, and then we'll switch to another piece of paper just to work it out. So here I have a 25-gram ball, so I'm going to go ahead and say mass equals 0.025 kilograms. I may not need that. Hint, I knew I don't need that because I wrote the problem. It's fired off a horizontal table 1.6 meters above the floor. So here's my table. And this is 1.6 meters. How fast do you have to shoot the ball so it's fired horizontally? V0. And I'm just going to call that the x velocity. Well, I don't know what it is. How fast do you have to shoot it so it travels a distance of 2.8 meters? So it's going to come down here, 2.8 meters. Okay. So there's my setup. Now this is a two-dimensional problem, and so once the ball's in the air, there's only one force acting on it, the gravitational force. And so that means that there is, in the y direction, there's an acceleration of negative 9.8 meters per second squared, and in the x direction, there's no acceleration. And the key thing here is that we actually have two one-dimensional problems. We have an x motion problem and a y motion problem. And these are independent motions except for time. The time it takes to do this is the same as the time it takes to do that. So let's write down everything we know about the x motion problem. So I know that it's shot with initial velocity v0. I know we can pick where it starts. I'm going to pick this as my origin down here. So that means the initial x is 0 meters. The final x, I usually call 1, let's call it 1 and 2. The final x is, we don't know, we're actually looking for, no, we do know that. 2.8, I'm sorry. 2.8 meters. The x velocity I know is, I don't know. And now I can write down my x equation. There's only one kinematic equation in the x direction that makes any sense. It's x final equals x initial plus v x initial, I'll call it x, times t. This is one of the kinematic equations. The acceleration is 0, so this just comes straight from the definition of average velocity. So I know this. So I know that and that. I don't know time and I don't know the velocity. So I can't solve for the velocity. I mean, I can subtract x1 and I get vx0t equals x2 minus x1, divide both sides by t, and this is assuming that I start at t equals 0. This really should be delta t. So I get vx0 equals x2 minus x1 over t. So I need to find t. Well, let's go over to our y motion problem. So let's do the same thing. My initial y position, y1, is going to be 1.6 meters. My y final is going to be down here at the ground, 0 meters. My initial y velocity is 0 meters per second. Why? Because I shot the thing horizontally. So right when it starts, it's not moving up or down. It has a 0 velocity in that direction. And then I know the acceleration in the y direction is negative g, where g is 9.8 meters per second squared. We use that as a positive value. For the y direction, since I have an acceleration, I can use the following kinematic equation. y2 equals y1 plus vy1, I call that 0, it's weird, t minus 1/2 gt squared. So I know that's 0, so this makes it a little bit easier. I know that's 0. So I get 0 equals y1 minus 1/2 gt squared. I can add this to both sides. I get 1/2 gt squared equals y1. I can multiply by 2 and divide by g. I get t squared equals 2y1 over g. So t equals the square root of 2y1 over g. Let's just check the units. Meters divided by meters per second squared. The meters cancel, the seconds flip up. I get seconds squared. I take the square root. I get seconds. Check. That doesn't mean it's right, okay? But if I get something different, it does mean it's wrong. So there's my time. I'm not even going to put in the value yet. I can put that in over here. And I get Vx0 equals, and I know x1 is 0. So I'm going to write this as x2 over t. So this is going to be the square root of g over 2y1. And let's again check the units. This is going to be meters, and this is seconds, so 1 over second, so that works. So let's say x is 2.8 times the square root of 9.8 divided by 2 times 1.6. And now we get to put it in my HP calculator. Drop for my last problem. So I'm going to enter 2.8, enter. I will say this. I like this calculator. You like a different calculator. Make sure you are skilled with entering things in your calculator, because you don't want to make parentheses mistakes, order of operation mistakes. Those are things that you shouldn't be making a mistake on. You shouldn't make a mistake on anything, but. Okay, so now I need to find the stuff inside of this before I take the square root. So I'm going to say, I'm going to leave that number there. I'm going to say 9.8, enter. I'm going to divide it by 2, so I'm going to say 2 divided by. Now I'm going to divide by 1.6. 1.6 divided by. So this is the stuff inside of the square root. Now I can just take the square root, and I get, where's my square root button? There it is, square root. So now I have that. I can just multiply it by the 2.8, which I already have there, 2. And I get 4.9 meters per second. A quick note, if you do like calculating this way, which I think is superior in every single manner, there are some RPN calculator apps on your phone. You could download a calculator app and then use that. I know there's some free ones. I used to use one. So mostly I use Python now, but my computer's over there. I didn't want to type it up. Okay, but there's your launch speed to get that far. The end.